All right. So I do want to say thank you for inviting us to speak today. It's really good to be here. And as she mentioned, my name is Erik Engh. I'm the environmental biologist for Marin, Sonoma Mosquito and Vector Control District. And today I'll give you some insight into our strategies for managing a particularly challenging species of mosquito, Aedes squamiger. This species is sometimes referred to as the California salt marsh mosquito, and its range is restricted to the west coast of the United States, from Bodega Bay in Sonoma County, south into Baja California. And although squamiger is associated with salt marshes, you don't necessarily have to visit a salt marsh to experience this species, as adults have a flight range of at least 10 to 20 miles and are quite willing to travel great distances in search of blood meals. The word pest probably doesn't do squamiger justice, as females are viciously persistent and the extreme biting pressure can make spending time outdoors practically unbearable. This species, along with another salt marsh dwelling mosquito, Aedes dorsalis, provided residents of Marin County the impetus to organize mosquito control locally over 100 years ago.
Erik, we are still on your first slide, so
Right.
not sure if, okay.
Okay, I'm
that
almost
okay?
done with the first one. Don't
Oh,
worry.
okay, so sorry
A
about that.
long introduction, sorry.
Okay, I'll
So
mute myself.
today, I'll give you some insight into our current strategies for managing what could be considered our most challenging species to control. I'll explain some of the reasons why squamiger is so tricky, describe our larval surveillance methods, and some considerations for larvicide applications, and I'll dive into an example of a source reduction project that I've been involved with. So our district is located in Northern California. It encompasses all of Marin and Sonoma counties, totaling approximately 2,200 square miles. Our boundaries extend from the Golden Gate Bridge north up to Mendocino County and extends east into Napa County, or to the Napa County border. Our district is heavily populated along the 101 corridor, with many smaller agricultural communities in the outlying areas, with dairies, wine production, and tourism being very important for our local economy. Larval surveillance is particularly important in management of this species. This map illustrates where we have collected squamiger larvae in the past decade, larger circles indicating higher numbers of larvae collected. We've found squamiger larvae at approximately 250 sites within our district boundaries, and we monitor thousands of acres of potential squamiger habitat. Collecting squamiger larvae can be trickier than for some other species of mosquitoes. If disturbed, they will dive and remain submerged for long periods of time, much longer than you'd want to hang around waiting for them to resurface. So care must be taken when approaching an area to collect a sample. One of our squamiger savvy technicians offers the following tips for successfully collecting this species. And as you look at the list, if you're wondering about the dirty dipper, it's much easier to see the tiny, nearly transparent first instar larvae in a very clean cup. After we collect a sample, we take it back to the lab. We identify all larvae to species as well as instar for our records. After emergence, adults migrate to nearby hills and other protected areas, and they can easily travel several miles into town for a blood meal and then back to the marsh to deposit their eggs. As you can see on the map, there's multiple sizable communities within our district boundaries, such as Petaluma, Sonoma, Novato, and San Rafael, that are easily within the flight range of this species, as well as numerous smaller communities that are not labeled on the map. There's also communities outside our district boundaries that could be reached by squamiger that developed in marshes within our district. As you probably know, this area is famous for wine production and associated tourism. Squamiger can easily ruin outdoor events at the many wineries located within squamiger's flight range, as well as make life unbearable for the many people who work outdoors, especially those working in the vineyards. As you can see, it's incredibly important that we successfully manage this species. Furthermore, even a relatively small fly-off has the potential to seed larger areas with eggs that may persist for years. As for adult surveillance, it's not uncommon to find this species in EVS traps, but the public immediately lets us know if any adults are present in their neighborhood. This chart shows where we've collected Aedes squamiger larvae in the past decade. As you can see, larvae are most often collected in the winter. Most of the eggs are deposited in the spring, high enough in the marsh that tides alone are unlikely to reach them that season. As spring progresses and waters recede, the remaining females deposit their eggs lower on the marsh. The eggs remain until a combination of higher tides and rain in the fall flood the marsh and eggs begin to hatch. And although this species is considered univoltine, the eggs don't all hatch at once. So if you're taking a quiz a little bit later, keep that point in mind. Additional rain events and high tides progressively flood higher in the marsh, exposing more eggs to the conditions necessary for hatching. Several additional egg hatches can occur throughout the season as water levels rise. The larvae from the initial egg hatch develop relatively slowly at first in the cold water and shortened day lengths. They eventually reach the fourth instar, where they can remain for several weeks before they stop feeding in preparation to pupate and emerge as adults. If a fourth instar larvae is still feeding, then products containing BTI can be very effective. But if the BTI is applied too late and the larvae has ceased feeding, then it's obviously ineffective. If it's applied too early, though, then there's a risk for this species that significant numbers of additional eggs are still going to hatch, depending on water levels, which could require additional treatments. If an insect growth regulator is applied too early, then an early fourth instar larva may still be able to eventually pupate, as it may remain a fourth instar larva for weeks on end. And if the methoprene is applied too late, you end up with lots of phone calls. As I mentioned before, timing of larvicide applications is extremely important and requires a significant amount of planning. In addition to closely monitoring the development of the larvae, we also have to consider the tides, the weather, site accessibility, application method, cost, and interagency cooperation, as well as other limitations. For squamiger control, we've had success using products containing methoprene and/or BTI, although we do work in certain areas that simply do not allow the use of methoprene in squamiger habitat. We often use liquid formulations, especially Vectobac 12AS and Alticid liquid larvicide, and we often use a combination of the two. There are also some areas with accessibility issues that make it more convenient to use granules, such as Vectobac GS, instead of liquid formulations. There are also some situations with heavy vegetation and canopy where we've had success with meadowlarvae. The equipment we use for larviciding varies greatly by site. We have a number of relatively small acreage sites with limited accessibility for vehicles that can be treated successfully on foot with liquid or granules. We also have numerous larger sites where we're able to use Argos and sites with ditches that are more easily treated by ATV. We also work in sensitive habitats where we cannot take vehicles directly into the habitat, but if we determine that larvae are widespread at that site, we have other options, including the use of an IntelliSprayer with a 600-foot long hose. If there's multiple larger acreage sites that require treatment, we also conduct aerial applications. In the summer of 2020, we started using Trimble TDC 600s to enhance our surveillance efforts in expansive areas such as marshes that require aerial applications. In the photo on the right, you see a Trimble TDC 600 displaying a satellite image of a portion of the Petaluma Marsh with some data points and treatment polygons. The TDC 600 runs an application called Trimble TerraFlex. TerraFlex allows field staff a simple interface to collect data and fill out form templates. The templates are created on a desktop program called Trimble Connect. The templates are entirely customizable, so you can include a variety of information that's tied to the geographic data that you collect. In the photo, the red dots signify locations where larvae were found during a marsh inspection. And green dots are areas that were checked but no mosquitoes were found. The template we built for recording the presence of mosquitoes allows field staff to quickly record the life stage and instar present, as well as relative abundance. Field staff can also easily add photos and notes when helpful. The TDC 600 units wirelessly sync, and the data from all 7 of the units we use is displayed and accessible on a map in Trimble Connect. This data is valuable for making treatment-related decisions, and if necessary, treatment polygons can be created and exported for aerial applications, like in the photo you see on the left. The data is backed up and can be viewed at a later date if necessary, and we've successfully used this technology throughout the summer and fall of 2020 for treatments primarily targeting Aedes dorsalis, and now we're utilizing the same technology as we prepare for squamiger season. The technology is also extremely useful for planning and implementing source reduction projects. These photos are from a tidal marsh where we've been involved in a multi-year enhancement project. These are examples of areas that did not drain adequately and would predictably produce Aedes squamiger and Aedes dorsalis. Water sitting in these areas for long periods of time resulted in areas devoid of vegetation, providing perfect mosquito habitat and poor habitat for certain more desirable species. The enhancement project aims not only to reduce the need for larvicide applications through source reduction, but to increase the habitat suitability for several threatened and endangered species, including the salt marsh harvest mouse and California ridgeway's rail. As drainage is improved, vegetation can become reestablished in these areas that previously couldn't support it, directly benefiting these species. The GIS technology gave us the ability to accurately map out these problem areas, visually share them with our project partners so that we could formulate a plan. This is a screenshot from Trimble Connect displaying the data we collected in the marsh with the TDC 600s. The data is organized by layers which can be turned on or off or exported and saved. For this project, we mapped existing ditches throughout the project area, which are signified by the thin blue lines. And in the field, we evaluated which ones appeared to be functioning well and which ones were silted in. We also mapped other features, including a recently constructed main channel, which is this thick blue line, as well as other marsh features, such as marsh mounds, which are signified by the orange polygons. There are also several problem areas that we mapped in the field, signified by the irregular, smaller polygons that indicate problem areas where drainage needed to be improved. We mapped out a network of proposed ditches that would allow for better circulation to present to our project partners, which include Audubon and U.S. Fish and Wildlife Service. During planning meetings over Zoom, the data was easily visualized and discussed, saving time and confusion. The technology is great for planning, but it's also useful for documenting the progress of the project. Yellow lines on this map signify the ditches that were completed or cleaned during the fall of 2020. Notes, photos, and measurements are attached to the geographic data point, polygon, or line and are timestamped. The data can also be displayed on a TDC 600 and used in the field at a later date to check and evaluate and record the source reduction efforts that have taken place and determine if more work needs to be completed.
Erik, 1 minute left.
1 minute, okay. Once we received approval to construct and clean circulation ditches, we used our modified snowcat with a hydraulic rotary ditcher for the smaller channels and an excavator for a single larger channel that needed to be cleaned out. And here's some before and after photos from this particular marsh. The area on the left would predictably hold water, produce mosquitoes, and we couldn't actually get our equipment into this area, so we dug using shovels, dug a ditch that drained it really successfully, and we're optimistic that we won't have to treat this area with larvicides this year. So the final photo shows a ditch that we installed a few years ago in an area that was often inundated with water. and had very sparse or almost no vegetation. As you can see, the vegetation quickly recolonized the area and provides valuable habitat cover for other marsh organisms. Thank you for letting me speak about our efforts in managing Aedes squamiger, and don't hesitate to contact us at Marin, Sonoma Mosquito and Vector Control District. And you see my email up there. You can email me anytime. Thanks a lot.